Hello, this is Taehyun Kim, and I'm going to resolve problem 10 from Midterm 3. So the question says that there is an infinite line of current I1 here on the z-axis, and there is a rectangular loop of current I2 here in the xz plane flowing in the clockwise direction as shown. So the current is going into the clockwise direction like this. And we need to find the net force on the rectangular current loop in this question. But before that, first I'm going to write the formula of force, which is F equal to current times the length of the wire times the magnetic field. By using this equation, we can find the direction of the forces. So when we look at I1 first, we are going to use the right hand rule. So point the thumb into the direction of I1, and then we can find that the magnetic field is going inside into the page on the right side. Now we'll write like this. Also, we know that the magnetic field is greater when it's closer to the wire. So when it gets further, the magnetic field will also reduce. So for example, here the magnetic field will be smaller than the magnetic field closer to wire. Then we're going to use the force right hand rule to find the direction of the force on the rectangular wire. Therefore, first we are gonna face the finger into the direction of I2. So face the finger into the direction of I2, and then put your palm, so palm of your hand, to the direction of the magnetic field, which is going inside the page, going into the page. Then you can see that your thumb is pointing left. That is the direction of the force. Also, then next we're gonna look at this one. Put your finger pointing to the direction of the current, which is right, and then put your palm to the direction of the magnetic field, which is going into the page. Then you can see that your thumb will be facing upward. That is the direction of the force. Same for the right side and the bottom side. If you use the right hand rule, the force is going into the right side on this one, and bottom to this one. Now we found all the direction of the net force, direction of each force on the rectangular wire, and then we can see and then we can cancel out the forces that are equal to each other, which is top and bottom. In this equation, when we are finding the magnitude of the force, it depends on the magnitude of the magnetic field. The magnitude of the magnetic field which will be greater on the left side than the right side, so that the force on the left side will be much greater than the force on the right side. So this force will be cancelled. Now we found the net force of the rectangular wire, which is going to left, and this is on the x-axis, so that we can conclude that the direction is going to minus x direction.